PC will be having, yes,
address of the next fetch cycle.
fetch cycle. So we say in a different way that PC will be holding the address of the next instruction. That's all.
Holding of next instruction.
Yeah, yeah.
So it will be coming after 8 bytes,
Correct, correct, correct.
not after 12 bytes.
No, 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 no.
So it will finish because phase cycle we have to forget about the phase cycle address, first phase cycle address, and
Correct,
after 4 plus 4, 8 bytes, we have to increment the next phase cycle
correct,
address.
correct, correct.
Okay.
Yeah. So I think Chetan, if he is there, he had also asked me some one question.
Good evening, sir.
Good evening, Chetan. Hi.
Sir, that read underscore U16.
Correct, correct, correct.
And I mean, will it hold 1 to 16 integer values, no, sir?
No, read underscore U16 means you are reading 16 bits of data.
Okay, sir. 16 bits of data.
Correct.
Okay, sir.
Correct.
Unsigned integer, no?
Sorry?
You
Yes. Unsigned 16 bit.
unsigned 16 bit.
Yeah.
If we declare in the instruction like that.
Yeah, I think it is on the accelerator part, no?
It is when we give the instruction, we have to specify whether it is
Correct.
16 bit or otherwise it will treat as 32 bit.
Sir, it will read 16 bit of integer value, no, sir?
Correct.
Okay, sir.
So, did anyone in between say something else? I might not have followed. Okay. So, read even 16 means it is reading 16 bits of unsigned integer. That's all. And normally in embedded system, it is always wise to work with unsigned integer. Okay, you don't have to necessarily work with signed integer. The reason for that is in that unsigned value, if you take the 2's complement, you automatically get the integer value. Okay, that's all. So I prefer to work with unsigned integers more because then I can tweak and I can interpret the signed bit in the way I like. So
that is, it can represent up to 6535.
65535, yeah.
Yeah. Okay.
Yeah. Okay, so I guess I'll share my screen.
Sir, any grace mark will be given for
I don't know. I have no idea. Absolutely. Okay, I have no idea. So shall we start with week 8?
Yes.
Yeah. Do you have any problem in the slides of week 8? Okay, feel free to ask. Okay, because I think it talks about accelerator.
Can't see your screen.
Still, you are not able to.
I mean, we are able to see the screen of your Google Chrome.
Yeah.
But not any present.
No, that's okay. I have not shared anything else.
Okay.
Yeah, I'll share and let you know. Yeah. So what I'm trying to say, the week 8 lecture is very important. Okay. See, this, from the real life perspective, this DAC, ADC, and accelerometer, they are very important. Very important in real life also. Whenever you do any kind of embedded systems, accelerator or gyroscope is something which you can do wonders with that. You can do a lot of projects with that. So be sure of, be very confident of this accelerator portion and study well. Okay. See, I'll tell you, these are very easy. Okay. The accelerator portion is very easy. Just think of the algorithm which is there inside. You know, right? Because accelerator is working on MEMS basis, on a MEMS platform. In that MEMS platform, you have a very small, in nano, one mass. Okay. Now there is a change in capacitance there. Now that change in capacitance is detected as the acceleration. So you can just think or visualize how much complex electronics will be there inside and how many good algorithms are there inside. So what you are getting, this the acceleration in this XYZ direction is just a byproduct of those very complex circuits and very good algorithms which is there inside the accelerator. Okay, so I mean, I am saying as accelerator, this is accelerometer. Yeah, so it is that good. So even if you work on, I mean, like I used to work on helicopters and fighter planes. So there we have something called HRS, attitude heading reference system. So if the HRS fails, the first thing the pilot will do is either eject or land the plane. Okay, he will not compromise. So it is that much important. The concept is same. It is just that it is not MEMS based. In aircraft, it is not MEMS based. They are more like light based. Okay, but the concept remains same, that you get pitch, roll, yaw, and then pitch rate, roll rate, yaw rate, and then pitch acceleration, yaw acceleration, and roll acceleration. And without these three or without these 9 parameters, you are nowhere. So treat this sensor as a very important sensor.
So it is also used in drones.
Everywhere, drones, it's a must. See, GPS can tell you your position, okay, but see, the problem with GPS is it drifts. Okay, so even for example, with your pitch acceleration, roll acceleration, and yaw acceleration, if you integrate twice, you will get the position, right? So there also you will get a drift and you will have an offset, but then you can always compensate that through other means. Okay, there are many complementary filters and all. Have you heard of Kalman filter? Anyone? Okay, so Kalman is a adaptive filter. So it's a predictive based filter. So it predicts the next location. Okay, so I mean that's the way the whole thing works. So there are very, very complex algorithms which are there inside. I mean they are not very, very complex in terms of implementation. They are very, very complex in terms of formulation. The way they are formulated. The Kalman filter was, I think, in 1960s or 1970s. So it is that old but very stable, okay, and very useful. But the maths formulation is very complex. So whatever we see in embedded system is just a byproduct of something, some research which has been done in 1960s, 1970s. So it is, I mean, it dates back that long.
So, sir, these IIR and finite
FIR,
impulse FIR response filters are used in digital power electronics.
Yes,
So,
yes. No, not
for
digital.
compensation.
Yeah. See, wherever there is digital, no, all of these are used. It is maybe in digital power electronics, maybe in digital signal processing, anywhere. Even if you're in your drones, everywhere. FIR. See, you need to have something on as the equivalent of analog filter, right?
Yes.
So the equivalent of any analog filter is a digital filter. And how digital filters are implemented?
By using Z transform.
Correct, but there are two structures. One is FIR, one is IIR. Okay. Not structure, I would say. They are the two forms of representation. One is the infinite impulse response, one is finite impulse response. And then you have other response also, like for other structures also, like polyphase filter. Okay, so in all these filters are there, but the basic idea is you have something in analog, you want to translate that to digital. So how do you do that?
No, we have to in analog we play in S domain. If you go in digital, we have to play in Z domain.
No, actually, in fact, if you see, when you go in digital, it is very tough to play in Z domain. Okay, it is very tough. Only for the stability of the filter you can talk about the Z domain. But if I ask you to visualize in Z domain, or even if I ask you to visualize in S domain, see, for us working in time domain and frequency domain is easier because we can get to see them in CRO and spectrum analyzer.
Hello.
But hello, are you able to hear me?
Yes, sir.
Yeah, so you can get to see them in spectrum analyzer or CRO, the time domain and frequency domain, but you cannot see a S domain, right? You cannot see a Z domain. You don't have any instruments to measure them. So that's why it is very tough for you to visualize. So whenever you implement, you always think of this either digital domain or the time domain, then only you can implement properly. For example, if I ask you to implement a IIR filter in C code, it will just be a difference equation of two static variables depending on the order. So I mean, from the implementation point of view, if you see, you have to always think on the time domain. From the analysis point of view, from the stability point of view, yes, S domain or to some extent Fourier domain, and then your Z domain is okay. Okay, fine, enough.
Okay, fine.
Yeah. So, shall we start with those?
8.
Yeah. 8. Yeah. So, question 1.
Sir, can you make the screen large?
Yeah, sure. Yeah.
C.
C
Anyone
and D.
else?
C, D. Humidity. भी
Sorry,
होता है.
B.
B. Pressure.
Tell me. Just, you want to visit the slides once again, or I mean,
Pressure.
Hmm?
F is
Acceleration.
Exactly, acceleration. No? It gives out acceleration, right?
Yes.
Yeah. Question 2.
A and B.
Anyone else?
A, B, D.
This one?
A, B, and D.
D. Why do you think it's D? It's a good observation, but why do you think it's D? See,
It actually measures the displacement along orthogonal axis, isn't it?
So it is also giving the displacement along the orthogonal axis.
So but it measures acceleration.
correct. And then Y acceleration, then Z acceleration, right?
Yes.
Correct. ABD. Okay, question 3.
Sir, what was the answer, sir? Second one.
ABD.
Can you show it again, sir?
Yeah.
Sir, but it doesn't measure
no.
displacement.
Yeah. So it's only A and B. Yes. Actually, see, the point of here is the principle of measuring displacement along multiple orthogonal axes. Yeah, true. It does not measure the displacement along multiple orthogonal axes. It measures the displacement only in one axis. For example, we have this x-axis. In the x-axis, it measures displacement only in x-axis. The x-axis sensor never measures the displacement of the y-axis, right? Clear? That's why you have this x, y, z, or else what would have happened is you have only one sensor which will give out these 3 acceleration x, y, z, but you have a mass connected in x, y and z in all the 3 directions, right? Hello?
It actually measured the
Sir, is it measured all 3 directions simultaneously?
Yeah, it measures all 3 simultaneously, but then see, when you connect the accelerometer, you will see x, y, z all 3 simultaneously. Okay, so it measures x, y, z simultaneously.
Simultaneously.
Yeah.
Thank you, sir.
Sir, multiple orthogonal axis means more than 3, sir.
Yeah, multiple orthogonal axis means, let's say, matlab x, y, y, z and
Is
z
it?
x, that way.
Okay, sir.
It's A and B only. Question 3.
What is the function of it?
Sir, one clarification needed.
Sorry?
One clarification needed.
Yeah, sure.
Can you show that question?
Yeah.
If that is, if the option D is the principle of measuring acceleration along multiple orthogonal axes, is it right?
Still, I would say no. Okay. See, how do they actually measure the? See, accelerometer is typically a movable mass whose displacement. This is okay, right? The first one is okay. The principle of, I would say, the principle of measuring acceleration in multiple orthogonal axes, not along multiple orthogonal axes.
Okay. In this case, it is showing that there is a plane XY plane, YZ plane, like that.
Yes, yes.
Okay, okay.
Question 3.
B and C.
B and C.
B and C. But then when you are seeing in Arduino, you are getting all these digital values, no?
No, analog values.
Good. So it is actually analog value, you pass it through ADC and then you get a digital value, right?
Right.
Correct. So yes, it is only B and C. Yeah. Question 4. Oh, wait.
Option A.
Anyone else? Okay. Correct. Option A. Question 5.
B.
Akka.
Option A.
D8
D8 is TX.
D8 is RX comma T.
No. Option B. Option B. Option B.
Okay.
Okay.
This one.
Sir, please repeat fifth for
Wait.
connection was gone.
Okay, okay. You guys are giving me the answer. Tell me which one.
B. Option A.
There is a difference, no, between A and B. So
B is the
just hold on. These are information. Just make sure, because information based question, no, I have to check. Hold on.
Is sir A?
I think it is A. I also feel it is A. But let me check. It is
B, sir.
no. Let me check. First is TX and then is RX. I also feel it is A. Just recheck, okay? Because I feel it is A.
Sorry, is it for embed or Arduino?
I think this is for the embed, no?
Embed program, sir.
So then it should be B.
The slide it is given as D8 RX, sir.
I understand, but in for example, in embed program also, like os.embed.com, I can right now see you have something called Bluetooth serial, right?
Yes.
The first one is TX and the next one is RX.
Yes, it not depends on D8 or D2. The first one is for TX and second one for RX.
Correct, true. But then that matches with this one, no?
Yeah, it's option A.
Correct.
So, sir, in the slide it is given as RX comma TX, sir.
Oh,
Yeah,
is it?
there is a confusion. Yes.
Okay. Just let me check the Arduino code.
Sir, if it is Arduino, it is RX comma TX.
Okay. Just let me check.
Yes.
Yes, it is Rx comma Tx. So for example, just make sure that what kind of what is the kind of syntax that they are giving. Okay. So for example, if this is serial Bluetooth, this is, I think it is for the Arduino, right?
Yes, sir. It is Arduino also, embedded also is same only.
No,
sir.
but embed, I think the function name is different, no?
No, sir.
No, sir. Same only. Serial
Serial Bluetooth
Serial
D8,
Bluetooth.
comma D2. Bracket D8, comma D2.
Then in that case, let me check. By the way, have you guys ordered this Arduino board or something?
Yes, ये board है हमारा. STM board is
STM32 is not available, sir.
STM board is with us.
STM32 is not available, sir, in market because they have new version of STM has come, sir. So they are not supplying this older one board.
Okay. So yeah, let me
Sir,
open.
can we purchase a smaller version of STM32 and connect it with the ST-Link programmer?
Yes.
Yeah,
that
yeah.
would work.
But only thing, you see, the correct way would be whatever programmer you have, just see the names of the controller it can connect to. Okay.
Yes.
I think the black pill and the ST-Link V2 will do.
Okay, then I have not seen ST-Link. I mean, I have used ST-Link, but I used it for Cortex A9, so does not. I mean, that depends. I'm not sure. Let the Arduino open, and then.
As for serial Bluetooth, it's first one RX, second one TX. It's actually serial PC, that is for accelerometer. It's first one TX, then RX.
Acha, okay. Okay. I'll have a check Bluetooth. Let the Arduino open. Okay. This question 5 will keep it on hold. Question 6. Question 6.
Yes, it should be none of these.
Sir, none of these are first option.
Yeah, first or none of these, right?
Yes. In first option, so few informations are missing.
Okay, what is
If
the missing?
not,
What is missing?
through serial interface Bluetooth module. If that would have been added, that would
Correct. So it's none of this. Yes. Correct. So in through this Bluetooth interface, instead of serial, if I write Bluetooth, then will the first one be okay?
and instead of message, if it is a communication, that would make sense.
Yeah, same thing. I mean, send this message and communication, they are all same. So, for example, if they have this Bluetooth interface, then you can say yes, okay?
Yes, sir.
What is the meaning of yaw?
Z axis.
Z axis.
Z axis.
Correct. Question 8.
X.
X axis.
Option A.
Okay.
X axis.
This one?
A.
Looks like A.
A and B. A and B.
Correct.
A and B, sir.
Correct. A and B, yes. Question 10. Wait, I'll open the full question.
A A and C.
A and C.
Can someone explain? What?
The period of the pulse is the entire pulse is 10, and the on period of the duty cycle in terms of time period is 5. So it's half of 10. So it's 50% duty cycle.
Correct. Good, good. So maybe we can talk about this. Yeah.
And last, sir. Make it
Sorry.
wide.
Right. Yeah. Hmm.
B.
Okay.
B.
Which role? Yeah.
Which
A.
role?
Role.
Option
which,
A.
yeah.
Ah,
A.
correct. So these are these confusing questions. Okay, just keep them in mind while answering. I mean, they really doesn't test your knowledge; they test your, the attention at that point. Okay. Question 3. It's the same here, I think. So just tell me.
B and D. No, false. Sorry, it's false.
Correct. See?
A and C.
It's A and C.
Correct. A and C. Question 4.
False.
False.
Question 5.
C.
Sure.
Data range of
Sir.
data 1 to 16 is not.
No, sorry.
Correct.
Sir, we need some explanation, sir.
Yeah. On what? Tell me.
That is under read under use U16 means what is that?
So see, A0 is coming as an analog pin, right? A0 is one of the analog pin. Okay.
Yes, sir. Yes, sir.
Now the ADC will convert this analog voltage to some digital value, right?
Okay.
So this digital value has a width of 16 bits. Okay. Now when data is being read, so what this line means, in data equals to input dot read 16. Now you know that once you have written a line like this, you can refer anytime A0 with input name, right? With the name input. So input has become the object. So you write input dot read U16 means whatever input is specifying, whatever input is taking the data from, which is this A0, you read it in 16 bits.
Okay.
Okay, so it may happen the ADC is converting only to 10 bits. It may happen, okay, but still the data will be of 16 bits. The less, the other 6 bits will be 0. That's all.
Sir, can you explain with a small example, sir?
Yeah, so for example, let's say that you have your analog voltage, which is, let's say 0, it can take from 0 to 5 volt, okay, and you have a 16-bit ADC.
Sir, we are not able to see that one, sir. Paint or something, editor, you can take.
Okay. I don't think I have again this pen today. So, yeah.
If it is more than 16 bits, then it will avoid.
Yeah, so it will saturate to 5. Okay, so let's say this is your ADC. Okay, this is your ADC. Now here you have from 0 to 5 volt. Okay, and this gives out 16 bits. So you know the resolution, right? You know the resolution. So it is like 0 will be denoted by 0 0 0 0 in hex. This is 0 cross. Okay, this is in hex, and 5 will be represented by what? 0 cross F F F F. Correct? Okay. It will be represented by that. Now let's say you give 2.5. So what it will get? It will give 0 cross 800, right? It is halfway. So the moment you this read, this moment, let's say you read this read event and this function, it will return to some variable, right? Let's say the variable is b. So b will right now have 0 plus 8000.
Sir, I read somewhere it is 12-bit ADC.
That's
like
okay. That's okay. For example, even if it is 12-bit, then the range will be from. I am just giving a general example of the ADC. For example, if it is a 12-bit ADC, what will happen? It is from 0 cross 0 0 0 to 0 cross 0 f f f, right?
Yes, sir.
Correct. So what will be the in between value? It will be 12-bit ADC, right? So 4096, it will be 2048. So it will be right 7 f f. Okay. So this 7 f f value will come to b. For example, the moment you give 2.5. Okay. So
Now we will see the option, sir. Now again we will see the option.
Wait. Yeah. So let's say your ADC is of 12-bit. Okay.
Okay, sir.
Yeah.
It should be none of these.
Yes, it's option D.
Correct. But is it clear why it is option D? For example, if it is 12-bit and for example, if I make here 2048, will it be right?
Sir, how do you know whether it is a digital data or analog data? Analog data, the normalized value is like you are saying that it is 5 volts, na, sir?
Correct.
What is this number?
Which number?
0 to 2048.
1
So
to
we-
2048. This is your data, no? This is your see. You cannot have 2 volts, 2.3 volts, 2.4 volts in digital, right? It will be
Okay,
some
sir.
digital value.
Okay, number. Okay.
Correct. It will be some number.
Okay.
So if it is a 12-bit ADC, and if I give this option C as this 1 to 2048, will it be correct?
But here it is not mentioned how much bit ADC.
No, I know. That's what I'm saying. Let's say it is a 12-bit ADC.
12-bit ADC. So 10-bit is 1024. 12-bit is equal to
Double value.
2048. 2048 12-bit.
So is it correct?
Then it is correct.
Now you revisit whether 12-bit is 2048.
Read values from analog input port 0 A0 and the range will be 1 to 2048.
Pakka?
If it is 12-bit.
12-bit 4096, right?
Correct. 12-bit is 4096, na?
4096. Okay.
So that's why what I'm saying that this kind of question might come. You might get a value here 1 to 2048, but then you have to see. I mean, how much is that value? 12-bit is 4096, right?
4096.
So keep all these things in mind while answering. That's all. Yeah.
I have a doubt in question number 1, sir. In the material I have read that, sir, can you show question number 1, sir? Sir, we can identify the location of the object. It is true, no, sir?
No, we can never. With an accelerometer, we can never do it.
Sir, it is hanging in a particular thing, na? So with respect to that one, I read in the material, sir.
No, you cannot.
It will be position. Its position.
Correct. No,
It should be position,
Yeah,
not location.
It is
correct.
different from location, sir.
Yes, location means you have this coordinate.
Coordinates. Okay, sir. Okay.
No, even if you say position, how will you do it?
With respect to some reference.
Suppose
How?
the inclination tilt.
No, that's okay. I have just hung it. So one value is g, one value is 9.8 meter per second square. It is giving only 3 acceleration values, right? The x acceleration is 0, the y acceleration is 0, the z acceleration is 9.8 because it is hanging, right? So how will you identify the location?
Not possible.
Correct, not possible. Unless until, for example, for a stagnant sensor, it is never possible to measure the location or the position. It is only when the sensor is moving, at that time you can get the acceleration, you can double integrate it and find out the position. But then also that position will be from the initial position. You can never say that yes, I mean over a period of time only you can tell the position. But if I, for example, if I keep it hanging or if I keep it stationary and suddenly I ask you from the accelerometer, can you find out whether, I mean, what is the position, you will never be able to find out. Okay, so keep that in mind. Yeah, so question 6.
Option A.
Option A.
Question 7.
Both are true.
Both are correct.
Question 8.
Sir, I can ask one question about that.
Sure.
That is a gas sensor, and that report is there on that module. Or that will set the value, and according to that, digital value will come out. Isn't it like that?
Yeah, right.
Like that threshold will be there. That is sensed through that pot.
Threshold
The
means?
pot is there to set the level.
Right.
And comparator is there, and it is giving digital output.
Right.
Either we can do that way, or we can detect analog signal and have
Absolutely.
a
Yes, absolutely. Yeah. Question 8.
Bluetooth.
This is very naive question. Question 9.
For the experiment with the accelerometer and MATLAB, how is the communication between accelerometer and MATLAB established? We haven't any idea.
Okay.
So using MATLAB driver, sir.
No, true. Actually, what it says is that your accelerator is connected to your embed, right? Let's say to your Arduino. Okay. Now Arduino takes the acceleration data from the sensor and sends via serial to the MATLAB. Okay. So that's why the correct answer is using serial communication link.
Serial communication.
Yes. So what this Arduino does is takes the data from accelerometer and sends to MATLAB via the serial communication link. Or sends to a PC. I won't say sends to MATLAB, sends to PC. Okay. Question 10. Sorry, wait.
A and C.
Correct.
Sir, is C correct answer?
Yeah, because that's what they are saying, no? With the potentiometer and all.
Sir, but potentiometer sensitivity cannot be adjusted, sir.
No, it is there, no, because you are sending this.
Digital.
You are changing the threshold. So, for example, let's say the sensitivity of the sensor means when you say the sensitivity of the sensor, it is the sensitivity of the whole IC. Okay.
Okay, sir.
So it might happen that the sensor is giving out output, but if your threshold is very high, you will not get the digital output. But if you keep your threshold low, you might get the digital output. So it is not the sensitivity of the core sensor; it is the sensitivity of the MQ2 total IC.
Okay.
Sir, please show me the 9th question.
Yeah.
What is the answer for this, sir?
B.
Serial communication. Okay, sir. Thank you.
Okay, so right now you tell me, how do you want to interact in the Friday session? Do you want me to go over the slides or how?
So we will revise total syllabus and come to know what questions are there.
Yeah, see, I don't have any other questions, okay. So, I mean, do you want me to ask some questions from the slides? That is the way.
No, we will go through whatever we have learned
Correct,
now.
correct.
Whatever the questions are raised in our mind, we will ask them.
Yeah, okay. So, let it be very interactive. Okay, then I will not post any questions because I think we have solved sufficient questions and you also have these questions from your assignment, right? I guess everyone has got the questions from assignment. So,
And sir, by that time we
Please
would
show question
revise all the
E.
concepts.
sorry, two people. Yeah.
Yeah.
Like on Friday, we will just take an interactive session so that by that time we would have revised our concepts over
Correct.
the all
ठीक है,
courses.
okay, done.
But that will be of some large duration, more.
Yeah, we'll try to do it between 8 to 9,
Yeah.
or else we will we'll extend it by half an hour.
7 to 8.
Not 7 to 8, 8 to 9.
8 to 9.
Yeah.
The final session will be of 8 to 9.
Final session will be of 8 to 9.
It will extend up to half an hour.
Yeah, it will extend up to half an hour. Or we will see how it goes, don't worry. We'll see.
Please show question 8.
Yeah.
For the final exam, the questions are all objective type, isn't it?
No, I am not sure. Actually, no one has told me anything about the final exam. So.
But previous questions are how they are placed, and we don't know.
We also don't know. I mean, I also don't know. So in that case, you have to ask the forum. I really.
It will be same as the assignment questions.
Oh, if it is Bluetooth, then if it is objective type, it is okay. No problem.
Sir?
If it is objective type, it is good only, no? Like
But
that.
how many questions are there? And
no idea. I think
there is no pattern actually. I gave 2 exams earlier this year. There is actually no pattern. There is no pattern.
No pattern.
Okay.
But all are objective.
The mark. It can be 1 marks. It can be 2 marks. All are objectivations.
All are. How many are there for 1 marks?
There is no pattern. I just told you.
Okay.
So how?
In one exam.
So which subject
In
did
one
you
exam,
give? So which subject did you give?
I gave for embedded system design. That was by Anupam Basu sir.
Okay.
And the other one was microcontroller and microprocessor. That was by Chattopadhyay sir.
Okay.
But if it is 1 mark, then it is 75 questions, or mixed.
No.
It will be mixed. 1 marks, 2 marks.
Okay.
For few questions, it will be 1 mark. For few questions, it will be 2 marks, and for few questions, it will be 3 marks. So they will
there may be a descriptive type also.
No. Everything is MCQ only.
Okay.
And you will be asked 75 questions. So in that you need to
not necessarily 75. It can be 50, but the marks will change.
Marks will change. Yes, 75 marks. So you will have approximately 40 to 50%.
Yeah, it depends.
Yeah. Sir, I have a doubt, sir.
Yeah, tell me.
Will accelerator can measure acceleration along multiple orthogonal axes?
Not along. I should be. It's in. For example, you have this XY data as orthogonal axis.
Sir, that assignment first question is so confusing, sir.
Acha. So,
I mean,
which one? I mean, the one.
First question, sir.
Okay. Just hold on. I'll mute someone. Yeah, tell me. First question means the one that they have posed.
Yes, sir.
They have given. Acha, okay.
Which of the following statement is or are false about acceleration?
I understand, but then I mean I was discussing previously the assignment questions which was given this time. Okay, the current assignment questions, but then I was told by PMRF committee not to discuss anything. So that's why all these questions are very similar to what we had discussed. Okay, I mean very similar to your assignment question. But what we have discussed, I can show you what we have discussed today, and that might help.
Okay, sir. Only share me the meeting recording, sir. Link.
I think it will be in this YouTube, no?
No, sir.
Oh, they don't give. It is there in
The
YouTube,
last
no?
2 weeks we didn't receive the links.
Last 2 weeks there was a delay from my side because I did not post.
Actually, up to week 4 or 5 only we had, sir.
I think
The
yeah.
YouTube link.
Okay.
Please provide us.
Yeah, I'll give you. Just hold on.
Thank you, sir.
Just hold on. I'll give you the entire playlist, okay? That way it would be nice.
Sir?
Yeah, hi, sorry. Wait.
Think he has
No, sorry. Yeah, I had to switch my account, okay? So that is the reason I got logged off this meeting. So I've just posted now. Just have a look. Yeah, Madhavan, yes, there'll be another live session before the exam. It will be from 7 to 8. Sorry, it will be, I think,
8 to 9.
8 to 9, yeah. 8 to 9 on Friday.
Sir, one doubt, sir.
Yeah, tell me.
So for a problem, if the answer is 0.3333, what the answer we should write, sir?
No, you can write, see, they will accept answers from 0.31 to 0.35. Okay.
Sir, I have given the answer as 0.33, sir.
Okay.
But they have given them a mark 0.
Why?
So,
How much is the answer?
The answer for the question is 1 divided by 3. That is, we are getting the answer 0.333. It is going on.
Correct.
I have typed the answer as 0.33.
Then you should ask them. Then there is something wrong. See, normally what happens is when I prepare questions, we keep this automation, okay, where your answer is between this range, then it is considered as correct. So you must mail them.
No, 0.33 was accepted.
In the answer, they have given it 0.30, 0.35. So I want to know what is the correct answer.
No, then it is okay. No, it should be between 0.30 to 0.35. That should
so
be.
We have to type as in the range 0.30 to 0.35.
No. If you write 0.33, then it is absolutely correct. That's what I'm saying. You can mail them. That why did the cut marks?
Okay, sir. Thanks.
Sir, hello. Sir,
Tell me.
In the week 8 assignment, if you look at the question number 5, I will just tell you, read U16 is a command, right?
Correct.
and which says actually that we have to read it in a 16 bit pattern, right? So in this question, if I'm going through the options, the first option says that uh, it reads an analog value in the range of 1 to 16, and other options are also there, but they are not correct. Like these options, this question says that about the different options, but none of these should be the answer.
Okay, which is the question? In the
Question number
assignment,
5,
current assignment.
week 8 assignment. Yes, sir.
Okay, just hold on. Let me open. I can only tell you whether the answer is there or not. Okay, I cannot tell you
Yes,
the
sir.
details.
Yes, sir. I just, because I searched for it on the internet about the same command. So none of means, as per the documentation that I have read, none of the options satisfy that. That is what I wanted to highlight.
Just let me see.
A should not be true.
Let me see.
And also others are also not in the correct manner.
The answer is none of these, I guess.
Question 5.
Yes.
Yeah, but you have something called none of these, no?
Yes, sir.
I mean, I don't know whether none of this is because I cannot tell you. But then, for example, if you feel that A, B, C, D are not the right answer, then it should be none of this. Correct, na?
Yeah, yeah. Okay.
Tell me.
Here it is saying the integer value ranges from 1 to 16. That's not true, isn't it?
Yes, yes. But here I just got that doubt because, like, as we are using STM board, right? So in that we are having 10-bit ADC. So, sir, how does that gets converted into 16
No,
bit?
it is just that you put zeros in the front, no? Let's say I tell you the value is 4, okay? The value of 4 is, let's say 0100. That is in 4 bits, okay? If I tell you I have to just convert it to 8 bits, what will happen? 0000
Okay, means it actually adds on to it so that it becomes balanced and gets fitted to.
Yes, yes.
Okay, okay. Okay, sir.
Yeah,
clear.
Yeah. Okay.
Sir, question number 3, sir. Whether we really require any header file for interfacing the accelerometer, sir?
Question 3. Where is it? In question 3.
Yes, sir. Yes, sir.
Oh, acha. You are asking me the answer. I just
No, sir. Because they have shown an experiment, but I have not seen any header file other than embed.h, sir. That's why I'm asking. No special header files, sir.
But yeah, I do understand, but I cannot discuss any of this. I mean,
no, sir. I am not asking answer.
No,
Can
I
you
understand.
any program with
They have directly
accelerometer?
started the serial communication in that program.
Correct. There is a reason why they have started communicating in serial, right? I mean, how is ADXL connected? How is ADXL connected to Arduino?
Receive and transmit, these two port pins are used.
Absolutely. So it is like ADXL 335. However, it senses the data does not matter. It sends to serial, na? So from the Arduino perspective, it is only the serial data, right?
Yes, sir.
That's it.
Sir, week 1, question number 6, sir.
Week 1.
Question number 6.
Yeah. Yeah.
Why C is not correct? No, sorry, D. D is not correct. In solution, they have provided AC. Yeah, AC they have provided. I'm asking why not D?
Yeah,
D.
because true, but then I mean, see, the reason for that is you are saying that why D is not the correct answer, right? I mean,
Yes, yes.
yeah. See, I'll tell you, there are many other components to embedded systems. Okay, so it is not the heart. I would say, what is the heart? The heart would be the power supply. If you don't give power to your embedded system, nothing will happen. Okay, so it is
Here
very
in the question, it's you have to mark the false statement.
correct.
And microcontroller considered as the heart of the embedded system. It's a true statement.
Yes,
Okay.
yes.
I changed false.
Okay, yeah, but since I mean it is nowadays what happens is it was previously like that, but nowadays what happens is I mean if you work on the really advanced embedded systems, right now embedded systems are not really the heart. It is I mean microcontrollers are not really the heart of embedded system. Okay, because the
Sir, the answers are correct actually.
which one? Which one?
No, the answers are correct. It is written that we have to choose the false one, and
Yeah, yeah, correct,
it
correct,
is
correct.
not false.
Yeah, yeah,
Okay,
yeah.
okay,
The heart
okay,
of the system is a true statement, so we are not selecting it.
okay, 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 okay.
It's very confusing.
Yeah. Yeah, tell me anything else. Any other thing? So what can be the next course that we can do in next sem of like
Sir, put down.
you can do that
Assignment.
you can do that ARTAS course, okay?
Which one, sir?
ARTAS course. I mean no. Madhavan has asked something, so I'm replying to him.
Sir, in one doubt, sir.
Yeah, tell me.
It is in assignment 2, sir. Same question 6, sir. You are having one option D, sir. LDR R0, R1 #8. It is register addressing only, no, sir.
Just hold on. Let me check. Which one?
Week 2 assignment, question number 6.
Question 6. Yeah, I think only the bracket is pending, no? Bracket is not there. I think the bracket is not there.
Which R1 should be given in bracket answer.
Correct.
Okay, sir. Thanks. The answer they have given only the B, sir. So I am asking this.
Acha, okay.
Thanks.
Yeah, so if there is nothing else, then shall we meet on Friday? And just all the best for your exam. Anyways, we will meet on Friday, but if you are not able to make it on Friday, just all the best. I am sure. I mean, don't worry. Okay. See, just for example, for those who have really given good exams or bad exams does not matter. Okay. What is important to you is the awareness that you have got from here. Unless and until you work on things or go deep, you are given sufficient time, you will not be able to feel the the importance of embedded systems. So treat this just like a course, just like a information center where you are getting more and more of information and awareness. Okay. What kind of things are available? How accelerometer gives the data? What are the communication protocols? You have now Bluetooth, GSM, all those things. So whenever you are working on some project, keep this course inputs in mind. That is more important. So for example, even if you score full marks in your exam and then you don't remember anything, then there is no point of this course. NPTEL courses should be treated like that. Okay. It's not exactly for your marks. It is more on the information center because I mean they are the professors. I don't know how much they teach in NPTEL and all, but the professors, they really know. Okay, and the reason they know, it's not because they are constantly studying. It's because they are constantly interacting with industry. They are constantly interacting with outside professors. So they are a huge information center. So they know many things. So I mean, whatever is there in the slides, that's okay. But even if you want to mail the professor and ask something, I'm sure they will reply. Okay, just keep these things in mind.
Sir,
Yeah,
Hello?
Shubham, yes.
Can I get the email addresses of all both the professors?
No, I think it is Indranil Sengupta. If you go to IIT Kharagpur, you will automatically get
Indranil Gupta and
Indra-
this
Indranil
Kamalika.
Sengupta, Kamalika Datta. I think for both of you will get. Go to IIT KGP site or you just search in net IIT KGP Indranil Sengupta. You will get.
Okay, okay.
sir, I just wanted to ask that if you can brief us about the RTOS and what's role it has in embedded system, like just 5 minutes.
Yeah.
Brief.
See this embedded system. The problem, I won't say problem, but there are few issues when you work on a large scale. Okay, let's say that all the sequence of operation is sequential. Okay, so let's say that you are waiting for some data from the UART. Okay, so unless and until you get the UART data, you cannot do the other task. Okay, the reason for that is those portion of the code comes later after UART. So unless and until you are getting the data from UART, you are never coming out of the loop. Okay, you are not going able to go to the other program. But with RTOS, what happens, the key feature of RTOS is multitasking. Okay, so what you can do is you can create task. And what is the use of this task? So the task is, let's say you have created one task, which is the example that I gave, that you are taking the data, okay, from UART, and in another task you are just multiplying two numbers, which has nothing to do with this UART. Okay, so what you do is the RTOS will constantly switch between these two tasks. Now in the previous embedded system, let's say if you write your UART code and then you write your multiplication of two numbers, then the multiplication of these two numbers will never happen unless and until you finish the UART option, right? UART data transfer, right? So first you will get all the data through UART, then only you will go to that multiplication, because that is the way sequential programming works. So RTOS gives you a feel of multi-processing, but it is not exactly multi-processing. It just switches between the tasks so fast that you get a feel that yes, it is doing both the tasks parallelly. But it is not doing both the tasks parallelly. It is just doing it step by step, but with a very small time slice. Okay, so what it will do is, let's say you want to solve this problem. So what you do, you create two tasks. One is the UART data and one is the multiplication program. And let's say that you fix the time that every 20 microsecond, the RTOS will switch between these two operations, this UART data and your multiplication operation. So you will see every 20 microsecond is not perceivable to humans, right? So you will see that UART data and this multiplication operation both are happening almost parallel. Okay, you will see in the printf you will get the output from both the operations, but actually it is happening sequentially. It is just that the RTOS switches between the tasks so fast. So that is the reason. So the most important thing is multitasking. That is the prime role of an RTOS. That is the reason RTOS came into market. It is because of multitasking, or in fact any kind of operating system. Now, why operating system can be called as real-time operating system? Because as you can see that when let's say you are working with your Windows, okay, and let's say you are copying one file, okay, let's say copying the file is one task and you are working in your, I'll explain that, concurrent and asynchronous, okay, and let's say this concurrent and asynchronous is almost same as what I am speaking, okay. So let's say that you are copying one file in Windows, okay, at the same time you are operating in Chrome. Let's say you are watching some YouTube video. So what will happen is, the moment the YouTube video is running on your RAM, okay, for a long amount of time, you will see first the copying portion will say it takes 1 hour, then sometimes it will say 5 hours, then sometimes it will say 3 hours, then sometimes it will say 20 minutes. So what it means is that the duration that is allocated to your copying task is not the same. That's why the copying task is not able to understand in how much time I should be able to copy the whole program, because the time given, the time slot given to the copying task changes dynamically, which is not the case with real-time operating system. With real-time operating system, everyone gets fair amount of slice of time slice all the time. So when you say in real-time operating system that I am going to finish a task within 2 minutes, you will finish the task within 2 minutes. Okay. So that is the use of using RTOS in an embedded system. Okay, so you are bringing in the feature of multitasking, operating system multitasking, but you don't want to compromise on the timing. So that's why it is called real-time operating system, which is very, very, prevalent nowadays in embedded systems.
Sir, it is having the concept of strings, mutex, and
But see, the reason for that is because when you have, for example, when you are having multiple tasks, now multiple tasks has to communicate with each other, right? So how will it communicate? Communicate. So it will communicate through semaphore, mutex, and all those things. So these are signaling mechanisms between the tasks.
So these are signaling mechanisms.
Correct. Semaphore mutex is never for message passing. It is only signaling mechanism. It is with the help of this signal you can actually do the message passing. So they are all signaling mechanism.
Sir, in RTOS, we can allot priority to each task if we want.
Yes, if we want, but normally in embedded system we do not do that.
So for that, we have to study all those scheduling algorithms.
Yes, but most
like
people, correct. But for example, if you go for round robin scheduling also, that is also very critical. So,
sir, can you brief on the hardware part also?
No, hardware doesn't change. Hardware changes only, for example, the same Arduino you are running now embed, or let's say normal program, right? In the same hardware you can put RTOS also.
Okay.
Now with Linux you need a memory management unit. So Linux is a very heavy operating system. So that's why you may need a memory management unit, because there are concepts of isolation, of that drivers isolation and this program memory isolation, driver memory isolation.
For that Raspberry Pi will.
Yes. Raspberry Pi also has got this memory management unit. Yeah. But don't go into that, I would suggest. First, when you talk about real-time operating system, I think if you talk about only round robin scheduling, that is much educative than your normal, you would say, this other kinds of thing that you are talking about. Because first your base has to be clear. So for that, even semaphore mutex comes much later in RTOS. First thing is the multitasking and the context switch. So the name of this switching between the tasks is called context switch. And the person who does that is called the kernel. So kernel is the heart of RTOS, real-time operating system. Okay. And you talked about.
Can it be called as an extension of the concept of interrupts?
Yeah, you can call. Yes, you can call it. Because in context switch you have a SysTick timer which interrupts.
Okay.
So, but when interrupt is being handled, the other functions they are deactivated.
Correct. It is true for multitasking also. When your one task is running, the other tasks are inactivated.
Yeah, but in RTOS we can run everything simultaneously.
No, never. If you see, when you say simultaneously, you mean that both the programs are running parallelly, which is not the case. In RTOS, it gives you the feel that yes, it is running parallelly.
Right. Due to the time slicing.
Correct. Exactly.
Right.
Yeah.
Okay, sir. Thank you.
Yeah, and Rajat, you spoke about this concurrent and asynchronous operation or execution. See, concurrent is more of a, I would say, when you say concurrent, it better be a multiprocessor system. Okay, where two programs are running concurrently. And asynchronous operation, it has nothing to do as such with the concurrent operation. Okay, asynchronous operation can be an interrupt. Okay, which does not follow the clock. Wherever your program is, wherever your processor is, does not matter. It is an asynchronous event. So it comes and hits the processor. So that way you can think.
Sir, you said actually the doings are done in the RTOS also in a sequential way, but there is no lag in that. How it is done?
No, who said no lag? Because see, I'll tell you, let's say that both of us are working, right? Both of us were working. So let's say I am working on, let's say that you are waiting for me to complete a task. Let's say only when I will do a task, I will complete on task, then only Arun will start working on the other task. Okay. Now let's say in between if I sleep in my task, then your time is wasted, right? Let's say I should suppose I should be able to complete one homework in one hour, and after the homework is done, the result will be used by you, and you will work for another 1 hour, right? Okay. So let's say so you are supposed to start after I complete my homework, but in between I have taken a nap. Okay, I have just slept. So you are getting delayed, right? Because you are supposed to start at one time, but because of my nap, you are getting delayed. So what happens is, right now, if you see that because this RTOS does thing, what RTOS does is, when I am taking a nap, it gives the control to you, so that you can start with your homework.
You said the example of Windows, copying a file and seeing a YouTube video. Then it acts almost simultaneously.
No, maybe it. See, in Windows it's a different case because you are having 8-core processor, right?
Yeah.
You are having a parallel processor, so there are parallel processing happening along with multitasking.
Okay.
But let's say
okay.
So it's a different case.
Yeah. Okay. And multi-threading.
Yes, Rajat, you are right. Yes. Concurrency is something related to multi-core or multiple processor. ASIC is single processor. Yes. Yeah, Arun, tell me.
It's somewhat similar to multi-threading like that, isn't it?
Yeah, see, there are two tasks. Okay, there are two ways of understanding this. One is multitasking, one is multi-threading. So multitasking is when you have one processor and you have divided your whole functionality into tasks. And then there is another way that, let's say you have 4 processors, you have divided your task. First you do multitasking. Let's say you divide your functionality into 4 tasks, and you take one task and divide it into 4 threads and give those 4 threads to your 4 processors. So multi-threading is possible only when you have multiple processors.
Or multiple cores.
Multiple cores or multiple processors, yes. Okay, so I guess we'll meet again on Friday. Okay.
So one question.
Yeah.
Suppose I want to interface OV2460 camera with STM microprocessor. Then means I wanted to ask you that should I directly interface that my camera with it, or
no, you can interface the camera, but then you need the libraries, right?
Yes, I mean obviously I will be using some libraries for that.
Yeah, so you can, for example, the only thing that is important is the power supply. Just check the power supply and check the pins. See, whenever you are interfacing a new sensor with a controller board, the first thing that you should do is check the pinouts of the sensor, okay, and check whether that is possible to fit with the microcontrollers that you are talking about.
Okay.
If those voltage levels match, then you can definitely connect.
Okay, sir. Thank you.
Okay. Chalo, bye then.
Bye.
Okay, thank you.
Bye.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.